Welcome to video lecture. Myself Ashwini R.K., Department of Civil Engineering, Rogni College of Engineering and Technology. Today we are going to see about fluid kinematics. What is fluid kinematics? The branch of fluid mechanics which deals with responses of fluid in motion without considering forces and energies in them. The study of kinematic is often referred to as geometry of motion. It is generally a continuous function in space and time. How do you define fluid flow? There are two approaches in defining the fluid flow: Lagrangian approach and Eulerian approach. Lagrangian method. A fluid particle is being followed at each point. The fluid properties are then determined as a fluid particle moves about. Consider an example: a woman following her pet around. She can observe the dog's every movement and its reaction towards the environment. She can also track the position and velocity of her dog. Similarly, in Lagrangian method, you can readily obtain information by just following an object's movement. That is, in this method, a single fluid particle is chosen and followed during its motion. Its velocity, acceleration, density, etc. is described with respect to its location in space and time from a fixed position at the starting of the motion. Eulerian, it's just an observing the fluid properties as a function of time and space. Imagine a container where fluid particles can go in and out. Only those particles inside the containers are observed. Now that is Eulerian. If we count the fishes that passes through the fixed space per hour, we execute the Eulerian method. We are only concerned with those fishes inside the boundary lines. Eulerian method. In this method, a point or a section is chosen in the flow field. Its velocity, acceleration, density, etc. are observed at that point. It is commonly used method because of mathematical simplicity. Visualization of the flow pattern. The flow velocity is a basic description of how the fluid moves in time and space, but in order to visualize the flow pattern, it is useful to define some other properties of flow. These definitions correspond to various experimental methods of visualizing the fluid flow. Path line and streamline. Path line, it is a trace made by a single particle over a period of time. Streamline shows the mean direction of a number of particles at the same instant at a time. Characteristics of streamline. Streamlines cannot cross each other, otherwise the cross point will have two tangential lines. Streamlines cannot be folding lines but smooth curves. Streamline cluster density reflects the magnitude of velocity. Dense streamlines mean large velocity, while sparse streamlines mean small velocity. Streak line and stream tubes. A streak line is the locus of a fluid particle that have passed sequentially through a prescribed point in the flow. It is an instantaneous picture of the position of all the particles in that flow that have passed through a given point. Stream tube is an imaginary tube whose boundary consists of streamlines. The volume flow rate must be the same for all cross sections of the stream tube. Thank you.